Hello guys, we back with a new video. In this video, I will show you how you can implement a code to find the histogram of an image and to show that values. You can get more information about the histogram uh, on the video lectures and the materials in the course. Okay, let's start with the code. Mm, First we have to add some module, high GUI, image processing, and IO stream. As you remember, we use these modules or libraries in most of our codes, and also some namespace such as CV or STD. Okay, let's go to the main parts of the code. Here, first we have to read and show an image, and you know that we have to make a new variable of the class of math to put the image on that variable, and with imread we can read the image. In this example, I will show you the histogram of an image in the grayscale, and in the next video I will show you how you can find the histogram in the color image. Okay, first we loaded the image, then we can show a sentence if it cannot load the image, and at the end we can show the image in the new windows, and we can put the wait key of 10 seconds for uh, continue with the rest of the code. To calculation the histogram of an image, first we have to define some variables and then we will use them in the code. And you don't need to read or make them several times in your code. You just need to make them one times and use several times in your program or in your code. But we have, as we are writing in the C++, one of the problem on this code is that we have to make each variable separately by their class. Okay, first we have to introduce this variable arrays for the number of arrays that we have. We want to use we consider this as a one. As we are working in the grayscale image, the number of channel is 0. It means that we just need the first channel. We can make a variable of hist to as an output. As also we are working in the grayscale image, we have dimension of 1. Then the histogram size is 256, and you know for the 8-bit image the numbers starts from 0 to 255. It means we have 256 values. Okay, then we have to consider a range for the histogram. It's as I mentioned, it's between the 0 and 255. It means that we have 256 values, and also we can make a constant by this. And when we define these variables or constants, then we can use calchist function, that is the built-in OpenCV function, to calculate the histogram of an image. It doesn't matter that you are working on the grayscale image or the color image. We can use this function as an input. This is the im variable that we use here to read our image. It's the input. An array, we just need one array to show the values, and channels. As I mentioned, we are working on the grayscale, and we have one channel. The class of math, hist, that's the output, dimension, histogram size, and the range that we define them here. And for showing this, we can write a loop for this, that I start from 0 to 10. I is less than 256, because we have to go for each pixel and count the value of that pixel. It means that we start from the first to the end, then in the range of 0 to 256, and at the end we can show the summation of them by using this, and by the sum here. At the end we can show it here. If we run this code, we can see that this is the values for each intensity. For example, we don't have a pure white in our image, and it's the original image. It says that we don't have any pure white. Pure white means the value of the intensity is equal to 0. Then when the value of the 0 is equal to 0, it means we don't have any pure white in our image. And also here the colors that's near to the white, you can see here. The first intensity, or we can call it the color intensity, doesn't matter. It starts from 25. It's very close to the white color, but it's not the pure color. We have one of these. It means that one pixel in our image has this value, the value of 25, and also 6 pixel have the value of the 26. It means that this is the near to the white, but it's not pure white. And we can come in this list. We can see, for example, we have around 2093 pixels that have the value of the 47. And again, we can come here, and you see that the most of the values are in this range between let's see this, between 28 till around 224, and most of the values are in this range. And also we don't have any pure black color in our image. As you can see here, then the value of 255 means that it returns the pure black. It's equal to 0. And also till here we don't have any pixel in this range. But maybe it's not good for us to have the values in this form. Maybe it will be better if we show these values as a graph in an image, or in a graph. To do this, we can write some code lines to show these values in a graph. Okay, for this we can define some variable. Max value 0, min value right now is equal to 0, and we can use the min max location to find the location of the minimum and maximum values. Here's the output of the histogram, calculation of the histogram. Min value, max value right now is equal to 0 and 0. Then we can optimize it with this, and also we can use hist image. By using this, we can write the histogram size here. 0 and 0 right now here, and the maximum value is 255. As we know, we are in the 8-bit image. Okay, and we can write this loop to show that values as a graph, and at the end we can show the histogram image in the separate uh, windows. And if we run this code, again, this is the original image, this is the values, and this is the graph for the histogram of image. And also you can see we don't have any white colors, or the color or the pixel that have the value of the zeros or 1, 2, 3, 4 or something like this. They start from, for example, from here, and also we don't have any values here, the pixel that have the value 255 and something like this. As you can see, it uh, we have the 1 pixel that have the value, that has the value of the 245. It means that we have it here, and you can see we have some peaks, and in this range we have the highest week. And that's it. You can see easily find the histogram on an image and show them on a graph. That's enough for this video. I will see you on next video. Have a good time. Bye.